Assalamualaikum warahmatullahi wabarakatuh and a very good morning everyone. So for today's video, we are from group 4. We'll be explaining our team assignment 3 for chemical product design classes. Before that, group 4 consists of Aiman Hakim, Muhammad Is Haziq, me myself Muhammad Amirul Arif and Tivia. So let's move on. So for team assignment 3, we are assigned to do the case study about dichloromethane, or called DCM replacement in organic synthesis. So the problem for this case study is to find the replacement for dichloromethane, DCM, which is a very well-known solvent used in organic synthesis. Note that DCM is a hazardous chemical whose release into the atmosphere needs to be strictly regulated. It is not only carcinogenic, but also when inhaled can affect the central nervous system. So this is the information given in the case study in the plant design textbook. So for structural constraint, it must satisfy equation 4.1 until 4.5, which is feasible, and then the n minimum should be 2 and n maximum should be 8, and only a cyclic molecule involved, which is CHNO, and then the basic set of group is 15 set of group, which is you can see here. And then for property constraint, it given boiling point, normal boiling point, normal melting point, the solubility parameter, and log P of octanol over water. So this is the information that will be used in the ICAS software to generate the molecules. So for the ICAS software use, will be presenting by Is Haziq and Aiman Jiwahi.
Assalamualaikum and a very good day to Dr. Azizul Azri bin Mustafa. I am Muhammad Ishazi from Group 4 and I will continue to explain on how to work on the ICAS to regenerate the results obtained for the DCM replacements. First off, we need to open the ICAS software and choose the program option in the task manager here. Under the general problem control, we can type DCM replacement as our problem title. For the section under here, we can refer the structural constraints given in the case study. It is said that the replacements should be only acyclic molecules with C, H and O atoms, and the N minimum is 2, as for N max is 8. So from here, we need to tick the generate isomers. For the pre-selection, since the DCM replacements will only consist of carbon, hydrogen and oxygen, we then take generate alcohols, ketones, aldehydes, esters and ethers. Then for the extended problem control, for the minimum number of groups, we just refer to the given structural constraints: minimum number of groups 2, maximum number of groups 8, minimum number of functional groups 0, maximum number of functional groups set as 8, minimum number of functional group 0, maximum number of same functional group 8, and then we choose to tick perform database search after generation. Moving on to the non-temperature dependent properties section, we need to add the parameters given in the property constraints from the case study. So we need to add normal boiling point, normal melting point, total solubility parameter, as well as the log KOW here. I have already insert the value for minimum, maximum and goal value for every each parameters here. For the normal boiling point, we need to untick the goal value. For the normal melting point, we need to untick the minimum and goal value. For the total solubility parameter, we need to untick the goal value. Then lastly, for log P octanol over water, we need to untick maximum and goal value. This is so that our results won't be hindered by such values. Moving on to the temperature dependent properties. Since there are liquid density here, we don't need to add the liquid density since it already stated in the case study that the liquid density is not a constraint in generating and testing the candidates. So we just leave the temperature dependent properties empty. Now we can run the simulation program by clicking the green button here. In this summary, it is stated that there are 2,691 compounds designed and there are 190 feasible compounds. There are a total of 40 isomers that are chosen that meets the requirement we inserted before. We can close the summary here. We can also open the summary back by clicking info here. For an example, the first compound that meets the requirement, we can know the name of the compound by clicking the data bank. Here, the name of this compound is 2-methylpropanol, and we can see that the properties meets the requirements stated in the non-temperature dependent properties. Since there are a total of 40 different compounds, we have already chose a few compounds that can be seen near to the results obtained in the case study, which will later be discussed in the conclusion section by my friend. Thank you.
Now I will explain the conclusion part. A total of 365 structures are generated which satisfied equation 4.1 to 4.5, but only 7 are feasible where they satisfy the property constraints. Note that the liquid density is not a constraint in generating and testing candidates, but all potential molecular products are checked to satisfy typical liquid density constraints. Okay, the table shows feasible DCM substitute molecules with their targeted properties. Okay, the feasible molecules are 2-methylpropanol, isopropyl acetate, methyl isopropyl ketone, methyl and propyl ether, ethyl isobutyrate, 1-pentanol, butyric anhydride. The targeted properties are log K, which represent octanol per water partition coefficient, solubility parameter, melting point, boiling point, and liquid density of the organic solvents. So these results are obtained from the ProChem software. Those are the 7 feasible isomers we get as a replacement for DCM. That's all from us. Thank you.